You all did a great job finding all the factors of your numbers and putting the models for the factor pairs on your posters. In a few minutes, I'm going to give you some time to walk around and look at each other's posters. But you're not just going to look at them. I want you to think about whether you notice any patterns when you're looking around. So what's a pattern? When have you used or seen patterns in your life? And how did you know it was a pattern when you saw it? One way we can think about a pattern is as something that's the same across, or similar across multiple examples of something. So one pattern I'm thinking about that you might know about is in your class schedule. So when you look at these start times, there's something similar about all of them. They all start at 5 minutes past the hour, 8:05, 9:05, 10:05, and so on. So that's the pattern because there's something that's similar or the same across all the start times. Or another example I can think of is in songs, in the lyrics to songs. It's pretty common to start with a verse and then we go to a chorus or a refrain, then we go back to a verse and then back to the same chorus or refrain, and then verse and refrain. And that structure of kind of going back and forth between the verse and the chorus is the same across a lot of different songs. So that's another pattern. It's something that's similar across lots of examples. So we see patterns all over the place in life, and in math it can be really helpful. Patterns are really useful because they can help us solve other problems or make predictions maybe about other ideas. So one of the things we're going to do this year is use a CT practice called pattern recognition. So pattern recognition is looking for ways that problems or solutions are similar or different to help me solve other related problems. That word recognition comes from the word recognize, which means to notice or see. So when you're doing pattern recognition, you're noticing patterns or seeing them when you look at multiple examples. So as you're looking at your classmates' posters, I want you to try to use pattern recognition and see if you can see things that are similar across the different posters. Let's practice doing a little bit of that together, and then I'll give you some time to work on your own. So your posters have a lot of great information on them, and there's lots of different ways you could look at it to help you see patterns. Sometimes when I'm looking at a poster like this, I like to focus in on the numbers. So if I just really focus in on just this list of factors we see for 15, I notice they're 1, 3, 5, and 15. I think to myself, those are all odd. All of those factors are odd numbers. I wonder if that's true for all numbers. Are all the factors of a number odd all the time? I don't know. I would have to look at some other posters to see if that's true. Because remember, a pattern is something that's similar across multiple examples. So we'll look at another one and check it out. So here's the poster for 12. And again, focusing in on this list of factors at the bottom. You have 1, 2, 3, 4, 6, and 12. Some of those are odd, but not all of them. There's some even numbers in there too. So it looks like that pattern isn't true for all numbers. So we haven't found something that's true for all numbers, but it still could be that it's true for some numbers. And maybe one thing you can think about as you look at your classmates' posters is what numbers is that true for? Which numbers are the ones that have only odd factors? That's one idea of something you could do and look for. There are other ways you could look at the posters too, though. Maybe you're more interested in those visual models. Let's see if we can notice a pattern looking at those. So I'm looking at these models for 12, and one thing that catches my eye is that it seems like all these models kind of have a partner where it's the same, except it's turned. So to help us check on that, sometimes if I'm trying to find a visual pattern, I like to kind of rearrange what I'm looking at to help me see it easier. So maybe I can kind of rearrange this poster or draw, sketch a different version of it that kind of rearranges it so I can see those pairs better. And I can draw arrows too to help me. That helps me. So it looks like that is true for 12. Each one of these has a partner that's the same, except it's just turned around. But again, to be a pattern, we have to see it across more than one example, right? And so let's look back at 15. Do we think this is true for 15 too? Do all the models pair up? In this case, it looks like they do, right? There's just 4 models here, and they do kind of partner up, so they're the same except for being turned. So far we know that that pattern is true for 12 and 15, but we'd have to look at more posters to see if it's true for all numbers, or if we can figure out which numbers it's true for. So those are just 2 examples of patterns you might look for as you look around at your classmates' posters. You could check which of these numbers have all odd factors. Can I figure out which ones those are? And is it true that all the models always pair up? And if so, for which numbers is that true? So I'm going to give you some time to walk around, and you can talk to a partner or a group about what you're noticing, and in a little while we're going to come back together and talk about what you learned. This has been a great discussion of all the great patterns you noticed. I wrote them down here so we can think about them more later, but there's a couple of things that I want to talk about before we move on. One thing that's important to think about when you're doing pattern recognition is, why do these patterns make sense? Why do we know they're true? Thinking about that can help you make sure you really have found a pattern. If it makes sense, then you know it's true. So, for example, we said that all the numbers, every single poster has 1 as a factor. Why does that make sense? Well, something we know about 1 is that when we multiply by 1, we just get the same thing, right? So any number we can write as 1 times itself. So that makes sense that 1 would be a factor of any number. So it seems like that would be true even for numbers we haven't found posters for yet, because we can make sense of that. It makes sense to us, right? Okay? And that also explains our second pattern, which says that all the numbers except 1 have at least 2 factors, because we know 1 is going to be a factor, and then the number itself is going to be a factor. So that makes sense too. That's probably going to be true for any number, not just the ones we made posters for. What about this third one? So we were thinking about that pattern with the pairing up of the models. All the models for a number have a pair except for the square numbers. Those didn't pair up. Why does that make sense, do you think? Can we figure out why that's true? Let's look at an example poster of a square number to help us think about that. So for 25, there's these 2 models that do pair up, but then there's 1 where it's just off by itself. It's the model for 5 times 5. And one thing that's interesting about that model is it's for a number times itself, right? And that makes sense. That's what a square number is. It means we can write it as a number times itself. And what would a model that pairs up with that one look like? So we said the models are the same except for they're just turned. But if you were going to just turn this one, what would it look like? It would just be the same, right? So it makes sense that the square numbers they're going to have a model that doesn't have a pair, because it just looks the same if you turn it. So that's why that pattern makes sense. All right, there's one more thing I want to think about before we move on. Why were we looking for patterns? Anyone remember why we were looking for patterns? I want you to talk about that with a partner for a second, and then I'm going to ask you to share. If it helps you, you can look back at our poster for pattern recognition to help you remember. You can raise your hand when you think you have an idea. Yeah. Yeah, we were looking for patterns because we thought it might be helpful to help us solve other problems, to help me solve other related problems. So let's talk about that. How could we use these patterns we just talked about to help us solve other problems? Let's think about this last one. So we figured out that odd numbers have all odd factors. Those were the ones that were all the factors were all odd. If I were to try to find all the factors of a different number. So I have a different problem I haven't solved yet. I'm finding all the factors of that number. How might this pattern help me? One thing I noticed when you were finding all the factors for your numbers while you were making your posters is that some of you tried every single number because you wanted to be sure you had found all the factors, right? So you tried 1, and then 2, and then 3, till you got up to your number. And it was good to be thorough. I thought that was a good strategy, but now that we know this pattern is true, how could that help us be more efficient when we're finding all the factors in the future? Yeah, say more about that. Yeah, so I think what she's saying is that if we're trying to find all the factors of an odd number, now because we know this pattern, we don't have to try the even numbers anymore. We know those aren't going to be a factor, so we can just skip over them. So that's half the numbers we have to try. It's pretty helpful, right? So that's one example of how we can use a pattern to help us solve other problems in the future.